Hello everyone, welcome to episode 4, part 2. Last episode we made it where we could segment our dialogue into different parts, and we see how that can be very useful in terms of efficiency for our writing, and it's also pretty clean because we're keeping it small and consistent, and it adds quite a bit more flexibility and power to our dialogue system. So in this episode we're going to do kind of the same thing. We're building, well, not the same thing, but same concept. We're building another data container for our speaker data this time, because we know that we can specify more than just a speaker name. We can specify a lot more information that's going to be cast to the speaker and cast to the screen, and we need to separate all that into the different parts. So that's what we're going to be doing today. So as we look in our dialog file here, I'm going to make a new line down here just to show what we're talking about, so that way we're all on the same page. So we normally have a speaker name followed by dialogue, and maybe some commands. Okay, well, we already know how to segment our dialogue with these squiggly marks. And so the thing that we're going to be doing for the speaker is the casting data. So instead of just having a speaker name, we could say the speaker is going to be speaking as someone else, so we could give them question mark, question mark, question mark, and make them an unknown speaker. We could make them whatever name we wanted to do. So we could specify who they're going to speak as. And we could also specify what position they might be at, such as 1 horizontally in UI coordinates would be the far right of the screen, and optionally the Y coordinate could be 0 at the bottom or 1 at the top of the screen. And then we can also define expressions for the different layers on our character, what images are going to render on each layer that makes up our character. And that's defined as the index of the layer, followed by the expression name after a colon there. And we can add more of those by separating them by commas. I said earlier we were going to be doing plus symbols, but I found it easier to write if we're just doing commas. And it looks better, and it's clearer that way. So we can specify another one. Maybe her face is on layer 1, and we could say that that would translate to the happy. And so what this will do is, instead of just showing our speaker on screen, it'll show our speaker, it'll bring them into the scene, if that's what we choose to do, but it'll show them displaying on the screen as this character name, it'll show them at this position, and it'll give them this expression automatically once we start saying this dialogue. So this is all the information that we want to be able to extract and do something with. In Unity, once more, let's make a data container as a C# script, and we're going to call this DL for dialogue line because that's what it's part of, and we'll call this speaker data. After that's compiled, let's go ahead and open that up. Alright, and again, remove update and start because we don't need those. There are a couple things that we're going to need for this speaker. Obviously, the very first thing that we want is a public string for the name of our character. This is the true name of the character. This is the name that's assigned to them, and it's the name that they'll be referenced by in the character manager once we get into that. So when we want to call this character on screen, we're going to use them by this name. But if we add a comma and also give ourselves a cast name, then this will give us two string variables, and this will be the one that renders on screen. So this will just be the display name. But we're calling it cast, that way we know exactly what that string is. And so when we're working on UI coordinates, we have the X and Y axis, and we want to store whatever position, the casting position, that we want this character to appear at. And we can set that as a vector2 and just call it cast position. And the next thing we want is those layers. So like I was saying, every 2D character, except with the live 2D, we're not so much doing anything with them because they have animations and motions and all that, but your typical 2D character, they can have one or more layers, and those are just having art rendered on top of each other. So we need a list to have all these layers, as well as what expression we want assigned to them. So we'll make a public list with an integer for the layer, and a string for the expression. And we'll call this our cast expressions. And if you're getting a red underline here, that's fine. It's because we're trying to define two objects for a list, which only takes one object. But if we combine these into one tuple here, then we can actually store multiple values at each index in the list. And that's pretty neat. And also exactly what we need here. So now, just like we did for dialog data, we need a constructor to create this. So public DL speaker data, we're going to take in a string line, and we'll say that this is the raw speaker. Okay? Inside of our dialog line, we need to replace this string with DL speaker data, and then has speaker, we will return that as false for now, comment out the rest of it, and set speaker once we create the line to new DL speaker data with the speaker that's been ripped from the line, and that includes all the casting data as well. Now again, we're looking for three things. We're going to be looking for three different casting identifiers. Just like we did for the segments where we were looking for the squiggly brackets and stuff inside of it, we're looking for as, we're looking for at, and we're looking for the bracket. All of these will identify casting information. And so we're going to use regex for this one as well. But we'll need to define a pattern first. And this one's going to be easier than the patterns that we made for dialog parsing and the dialog segmentation, because we're only going to be looking for 3 words, which means it can be much simpler. So our string for the pattern is going to equal these 3 words. All of them are going to have spaces in between them, so our as will be surrounded by 2 spaces, and then we'll give ourselves a pipe to give ourselves a new choice, or a new word that it's looking for, and then another space, at, another space, pipe, another space, and the last one that we're looking for is the bracket. But of course in regex, the bracket represents another symbol, so we need to backslash that. And to prevent this error, we could backslash our backslash, or we could do like we did for the dialog segmentation and precede this with an at to make everything literal. And if you wanted to, while we're on the subject of literal strings, we could do something here as well. Don't hate me for it, we should have done this earlier, but to prevent us from having to backslash our backslashes, you could just add the at symbol to it. So we can remove these extra backslashes on our command regex pattern on our dialog parser, and it'll work just the same. But back to the speaker data, now we need to do something with this. We need to get all the matches from the raw speaker that we've passed in. And we can do this, of course, by not deleting my semicolon. And we could do this by specifying ourselves a match collection for matches to equal the matches for our raw speaker using this pattern. And now, of course, that we may not actually be using any casting data. It's just an option for us. So if we don't have any, then we won't have any matches in this list, obviously. And if the match.count equals 0, then what we want to do is just go ahead and return this line as is and do nothing with it. So we can say name equals raw speaker, and that's it. That's all we need. And just to prevent any null values, you could come in here and say cast name equals the quotes, and then cast position equals vector 2.0, and cast expressions equals new list empty, and then just return. It depends on how you're going to look for these values. If you try to access them, see we're not defining them up here, if you try to access them later, you could get null reference exceptions and be like, what the heck's going on? So we'll just go ahead and populate them with empty data if we see that nothing is happening here. But if we've made it this far, if we have not returned, then we know that we do have matches. So now we can go ahead and find our first match and grab our name, separate it from the first match, and then go from there. And this means that what we want to do is we want to find the first match and say that everything after that is just our casting data, and so everything before it is our speaker name. We just want to grab our speaker name real quick. And to keep track of where we're getting all this casting information and like moving from one to the next, we'll want to keep track of our index again, just like we did for dialog segmentation. So let's make an int for our index and set that to equal matches 0.index. And with that, we can come in and say that name equals raw dial or raw speaker. We say name equals raw speaker dot substring starting at the beginning of the line proceeding to that first match. And now for this portion, we may not have all of the casting values, so we want to make sure that just like in this check, we populate them so we don't have any null checks or null error references. And so instead of putting that in two places, let's just actually cut that out and put it above here. So no matter if we have matches or not, we're going to populate this. Okay, now that we've got all that, it's time to loop through our matches and find out what's what. We'll loop through each one and get our current match that we're on. And now let's go ahead and run through each of these and check which one we have. That way, we're not enforced to any particular order, but they can be in whatever order we desire. So let's check for our first one. If match.value equals, and what we're going to be looking for is as. And now there is one thing that I should mention here before we go any further. The worst thing you can do is hard code strings like this. In some cases, it's okay. But in a lot of cases, what you want to do is define them somewhere else where they do not change, and all you have to do is change one reference of that variable to change it across the whole script. You can see we've already got it in two locations here. And this might be something that you want to customize. So maybe you don't want to say as, maybe you want to do something else. And if you wanted to change that for any reason, you'd have to go through each instance where this is occurring, instead of just one centralized spot. So instead of us manually defining this at each spot, so let's go ahead and set up a constant that we can reference throughout each point where we want to find this string. Inside of speaker data, we'll just make a couple instances here. So private constant string, and this will be namecast ID, and that's going to equal as. Then we check if match.value equals namecast ID. Okay, so then what can we do here? Well, what we can do is simply precede the @ symbol, or you can put it after the @ symbol, doesn't really matter. As long as it's outside the quotation mark, then we can then come in and give ourselves a field here where we can reference the namecast ID, just like that. So that's going to fill in our pattern, and let's just do the same for the other ones. So namecast ID, we're going to change that to positioncast ID and set that to @, and then the expressioncast ID, and that's going to be our bracket, which I'll make that a literal. And then inside of here, let's get rid of our spaces because we're including the spaces. Our second option is our positioncast ID, and our third option is our expressioncast ID, and that'll work just the same. So now, if our match is our namecast ID, or as, we can do something. We need to find the starting index for what we want to rip. And we also want to find the ending index. So we want to isolate the very content we're trying to grab out of here. We know that as has 4 characters in it. So we're obviously going to need to go past that to find the content that we want. But of course, if that changes, we need to reference our ID here. So we can define the starting index. Let's actually move that outside of here because we'll be referencing all of those together. So int start index equals 0 and end index equals 0. So we got both of those indices there. And so our start index is going to equal our match.index plus our namecast ID dot length, which would be 4. And now we need to define our end index, and that's going to be different depending on if we have a match that precedes this or not. So if I is less than matches.count minus 1, if we have a match, then we're going to want our ending index to be matches I plus 1.index. Otherwise, we want to set it to the very end of the line. So raw speaker dot length. And from there, we can grab our casting name. So cast name equals raw speaker dot substring starting at the start index, moving to the index or end index minus our start index. That will effectively grab whatever name we're trying to cast to. So that's one of our options. Otherwise, if match.value equals our position cast ID, then we want to do something similar. Okay, let's go ahead and copy this because it's basically the same thing. The only thing we really want to change is our position cast ID. And now what we've got inside of here is we've got a string cast pose, and that's going to be equal to, we'll copy this line and paste that there, because that's grabbing the same data from the same index, just starting at wherever this occurred at. So same data there. But what we have is a string that could either be 1 or 2 values. Okay, so let's split that to see if we have a y coordinate to go along with our x coordinate. And it's pretty normal for us to use the colon, but again, maybe we don't want to do that. And if we reference that in multiple areas, it'd be nice to have it up here. So private constant string, and this will be our axis delimiter. Is that how you spell that? No, it's not. Just like on a test, had it right the first time. All right, so our axis delimiter ID. And we're just going to set that to, oh, it's not a string, it's a character. So there we go. That's the symbol we're going to be looking for. Okay, so string array axes will equal our cast pose dot split, and we're going to split by that delimiter that we just made. Axis delimiter ID, and we'll say system.string_split_options.remove empty entries, just in case we made a mistake and specified X but not Y, even though we had a colon in there. Just kind of a safeguard for us. So the next thing we need to do is just try to get that data. Just to make sure if it's a number or not, we'll try to parse it. So float try parse, and we'll try to parse axis 0 to get the x-axis first. If it works, we want to cast it out to the cast position dot-x, and we want to do the same thing for y, but only if our axis.length is greater than 1, which means we do have a y-axis. So we'll say float.tryParse again with axis 1, and then out to the cast position dot y. Okay, and that effectively gets our position. So now we've just got one more thing we're looking for, and that's the expression cast. Okay, so else if match.value equals expression cast ID. But hang on now. Our expression cast was passed in directly to regex with this thing, which has a backslash in it, whereas our ID does not have a backslash. It only has a backslash, so that way it's compatible with the regex pattern here because I'm using a square bracket. So how about instead I remove that, we could remove that and just have our bracket. And since I know I'm using a bracket, I'm going to do something special here. I can't just put a bracket beforehand because I've got, not a bracket, a backslash, because I've got this space there. But what I could instead do is say insert, and I'm going to insert something at this particular index. This is going to be my expressioncastID.length -1, and what I'm going to be inserting is that literal string for the backslash. But I put that in the wrong spot. Need to take that and stick that inside the parentheses there. There we go. So I am manually injecting that just into my regex search here. That way I can use this for the check below, and I can also use it inside of regex. And that is just because I know that I'm using this particular character, so I need that backslash in there. Obviously, this would be different for you if you're using some other symbol that is not a reference to an action or identifier in regex. Okay, so if our match is this expression cast, again, we want to grab our start index and actually grab all of that, paste it in here, paste it in there. That was a combination of pass and paste, if you were curious. And expressioncast.length is what we want to look for. Okay, so then all of our expressions will be separated by, well, I said a comma earlier. I'm once again going to come up here and just to have this all in one spot where I can change it very easily if I want to. I'm going to make a constant character for that comma that's going to separate the layers. So this will be expression layer delimiter. I want to trying to spell it wrong again. I'm going to remove ID off of these. And that's going to be equal to my comma. Okay, and one more. Private constant character for expression layer. And I should make this one my delimiter and make this one my joiner. So the joiner that joins expression casting together is a comma. And the delimiter that separates the layer from the actual expression that I want to put on there is going to be that colon symbol. Alright, so let's grab our cast positions. So let's say our cast position, not cast position, cast expression. Good lord, I need to get some rest. Alright, so cast expressions equals, I put cast pose here. Oh, that's because I copied it. Okay, I'm doing myself in. Okay, so it equals cast exp, and then we want to split it. We want to split it by that joiner, so we get all the individual expression layer combos. So we can split it by that, and this is going to turn it into an array. What we're looking for is a list, and that list is not just one item, but it has the layer and the expression. Okay, so this is going to split just into individual strings, which is a layer expression combo. So we need to go a little further than this. So what we're going to do is use a little special method called a link query. And what this is going to do is we're going to access a function that's already native to arrays. If we have an array, which is what split is returning, we can specify select, and we can do something with the data that we're getting. So we'll specify that for each object, we're going to call the object x. And when we're splitting, we've got this array of strings, so x is going to be each string inside of the array that we've just split. To do that, we'll pass it in as the argument for what we're working for, and then we're going to specify what happens to x. So let's move this to a separate line for neatness here. And what we're going to do with x is this. X is a combination of both our layer and our expression to go on that layer, which is separated by the colon. Okay, so we need to trim that to get rid of any white space that might be on the edges that might get in the way of like the name of the layer or the name of the expression, and we need to split those two values from each other. So we'll say var parts to hold the array that we're about to build here, and we're going to set that equal to x, which is the current string we're working with. We're first going to trim it, get rid of any excess white space, and then we're going to split it by our delimiter, which is my expression layer delimiter, the colon up above. After we've done that, we're going to return to this array that's being built. We're going to return this, the layer, which is actually an integer. So we need to do int.parse and pass in parts 0. The next item is just the string, which would be the name of the expression, and that is parts 1. And what we need to do, since we have cast expressions, which is a list, we need to convert this to list and end it just like that. Okay, looks a little complicated, but basically all we're doing is splitting this into an array and making it where each item is automatically split from the other, turned into an integer for the layer, and a name for the expression, which would really be like the image that we want to apply to the character. And that's it. That's all we've got for the speaker data casting. So we can actually go ahead and start testing this now and make sure that everything works. After I get rid of these extra namespaces up here, I know that Visual Studio loves to do that to me. Okay, so back in our test dialog files, let's go ahead once again and just stop our dialog system from saying anything, because we just want to examine the text inside of these lines. And here I've got a small little function that goes through each line, and it's basically just going to print out everything. It's going to print out the speaker name, and then the casting name, as well as the position, and it's going to print out each layer and each expression that goes along with that layer. So we can see if our system is truly working here. In order for us to do that, we need to have something to test. So I'm going to remove all of this dialog, and I'm going to make a new one that does something like this. We'll say Ellen as question mark and some dialogue. But of course, once more, if we jump in Unity, we're going to see that we have an error here at our conversation manager again, because we need to change the data type that it's expecting. It's of course expecting a speaker name here. What we need to do instead is get the name of the speaker. So we've got the name, or we've got the cast name. So how do we know which one that we need to show on screen? If cast name is set to nothing, then we need to show the regular character's name. Let's just make ourselves another variable inside of speaker to make this a little easier for us. So in our speaker data, underneath name and cast name, what we'll do is make another string called display name, and this is going to equal, if our cast name is not equal to string.empty, then we're going to provide our cast name. Otherwise, we'll just provide in the regular name of the character. So then line.speaker can simply change to line.speaker.displayName. If you add a summary field, it'll be a little easier to know what's what when you're assigning it, as Visual Studio and other code editors will show a description of the variable. And now we enter back into Unity, and we've got no errors, we got a clean console, so let's fire it up. Okay, so I've got a bunch of lines here. Once more, I need to implement my check and only do this if the line is not null. So as I run this, I don't get anything in the console. It's like it's not reading my lines. And this is a case of me using autocomplete and not seeing that the index was just set to 0. So I need to change that to I. Okay, and loading back in, we can see it's parsing our line and identifies Ellen and identifies her casting name. Okay, and then I've got the casting name, I've got the position, and that one had no expressions on it. But if we come down to the bottom, we can see that when we have Ellen as question mark with all these expressions at the 0 position, we sure enough get the casting name, the position, and each one of these layers laid out in here. Except you'll notice that the very last layer has this bracket at the end of it. So it's capturing the very end of it. So we need to remove that bracket from the expression cast. And we can do that simply by coming in here. When we subtract the end index from the start index, let's just tack 1 on to the end of that. And with that small change, each of our layers gets the expression name correctly. And we can see that indeed the order does not matter because we have at switched for as, and then as before at, before expressions. You can put it anywhere you want and it doesn't matter because the system knows where they are and it's able to get each index for each one of these. And so we've got all of our casting data here ready to do something with once we start actually working with characters. But what about our conversation manager? It's looking to see if we have a speaker, which has speaker is set to false right now. It's not doing any kind of logical check. So we'll simply make this a null check. And we'll say if speaker is not equal to null. If we do have speaker data, then we're going to have a speaker, which means down here, instead of just assigning it, we need to first check if our speaker equals string.empty, or maybe we have white space. So let's put all this inside of parentheses so that we can group it together and say if string.isNull or white space speaker, then we'll set the speaker data to null, otherwise we'll set it to a new instance of speaker data. And so in test dialog files, let's go ahead and remove all that since we know it's working, and send this to our dialog system. And we can see, yep, it is getting our casting name right in there. We get it, changes, goes right back, looks like it's all good. So this isn't 100% done and over with now. I mean, we're done with the parsing. We're not going to have to parse anything else for the character casting. The only thing that's left is the commands, and we'll do that shortly in the next video. But this isn't done with the implementation, okay? Because you'll notice that you're going to have to define the casting name every single time. We'll eventually get into, once we start working with characters, we'll get into character data sets. They'll have their own data, and then if you cast a name, it'll basically be saved in there, so you only have to do it once. As well as the other information with setting our position on screen and setting the expressions. But everything that we really need to get that going is in place. We can parse it, we can get all the data, we can put it in its appropriate fields, and we are good to go. So that concludes this video. We're done with our dialogue, we're done with our speaker casting, and now we just need to get our commands rolling. So we'll take care of that in the next video, and then we'll get into characters.